Hey there! My name is Brandon Howe, and welcome back to my Making a Game series. In the last episode, we fine-tuned our enemies a bit more with their speed values, making them a lot smaller, and so we can have more in bulk. As well, we made a new type of power-up, which actually, if I'm going to want to show it off, I'm going to want to go over to our enemy manager and make these numbers super small. Just for the moment, we made a new power-up, a gun power-up that allows the player to temporarily have a triple shot. Oh wow, we got that right away. Cool. So now, well, our power-ups are going to spawn in like crazy. So in addition to our shield, we now have this triple shot when I'm able to get it. We're getting a lot of shields here. Just the luck of the draw. Alright, 50-50 chance. Yeah. Alright, so now we got a triple shot here. Now we can completely obliterate lots of enemies, except for, yeah. Alright, so, cool. Now we got that done. Now, I want to experiment with something. I want to try and have different camera modes. So I'm going to go into this again for a second. I want to try and make a system so that maybe we're going through a level and then we pass a certain trigger and then we have the camera do this, where it'll switch to being like 90 degrees and then you'll be moving this way, and then maybe it could switch again over to the right, then you're moving this way or this way. Something like that. I mean, we could do like a 45-degree angle thing, but I don't think that would be ideal. It would be tricky to get to work properly. But, so for now, we'll just stick with the main four axi, whatever. So how we're going to do this is we're not going to actually turn the player, we're just going to turn the camera. As well, to account for that, we're also going to need to change the player's input so that up still goes up, down still goes down, left and right, they still go relative to the camera. As well, we might want to temporarily move the player to the center of the screen, disable their movement, turn the camera, and then re-enable their movement. And also use that as an opportunity to move the boundaries around, so that they still line up with the camera so you don't go off screen. Now, one thing I do want to do first, so way back when we set up our player boundaries, we had them like this, so the player can only really go in this bottom part of the screen. I think I'm going to change that. I'm going to take this top boundary, move it up a lot, and allow the player to go basically anywhere on the screen, just because. Now, usually, in my experimentation, I would say that it'd be better to be lower on the screen, but we'll let the player decide that, I guess. So I'm going to move those up and then set this to 20. So now our boundary goes everywhere on the screen. Also, the left and right boundary, I'm going to just extend them, I guess, to 15. Yeah, 15 on both sides. Alright, so now... Oh, I did that all in edit mode. Oh, no. Go out of edit mode and then reset those, which is fine. Setting those both to 15, this to 5, these to 20, and then this went up to 15, 13. Yeah, alright, so now we have that, and they're still square around. Cool, so now let's get into messing with our camera. Actually, as well, another thing that we're going to want to do, we don't just want to move the camera, we're going to want to turn our space background as well, so it looks like the player's actually turning, I guess. Yeah, so, actually, wait, do we? Let me just test something really quick. So going in here, so going this way, turning the camera would do that. But it's still moving forward relative to space going that way. What if then I take the background and were to also turn it 90 degrees? Does that look good? Is it still going the same way? Negative 90? Or are those still... I think no matter which way I turn it, it's still moving that way. Maybe that actually, I think that could look cool for a turning effect. Yeah, it like still looks like space is turning, but we're still... Okay, yeah, I think that this works. Alright, so like we will want to turn the background as well. So we're going to make a new object that's going to be the turn pivot. And we'll rotate this object instead. We'll zero that out. Yeah, except actually we're going to want to give it the same Z position as the camera, sort of be in the middle of the screen there. So we will do that with a Z value of 5. And then we're going to want to take our camera and our background and make them child objects of this turn pivot. So going into play mode, again, just to sort of experiment with this. Now if I turn this, it should kind of... Maybe. I still think... Okay, maybe what we could do is on all of our... the thing that moves our stars and all that, we could... Okay, so position.x times... Yeah. No, yeah, alright. We'll just leave it like this for now. I think that's fine. Let's focus on the actual coding of getting the turning to happen. Then we'll actually see if it looks good or not, and then we can change that stuff around when we get to that point. So now we're going to then want to make some new scripts here. Now to actually turn the player, I'm going to go and I'll take all of our enemies after our hazards and move them back a bunch, because then we can have, we'll go through this phase, then hit a collider that'll turn us, and then we go through the next set of enemies. Just sort of experiment with that, and then another trigger that sets us back to normal. Just being kind of, yeah, test it, I guess. So we're going to want to then make an object, or a trigger that'll activate our switching camera thing. So we're going to want to go 3D, or creating an empty, zero out the Y component, zeroing out the Y component and the X component, and then the Z will be the only one that matters. I'm going to set it to 40, just a little bit after this last hazard. Or, yeah, right there. And then I'm going to add a box collider. And we're going to want the player to hit this no matter where they are on the screen, like left or right. So we will set this to 30 and maybe just 10 on, maybe 5 on there, just to be, I'll make it too high. Just to make sure that they hit it. We're also going to want to make that a trigger collider. And then we're probably going to want to then, we'll call this turn trigger. Now, then we could either have when the player interacts with this, then turn, but we're going to want the different turn triggers to, I guess, keep track themselves of which way we're going to be turning. So we'll have to create then a script on this object so that when it collides with the player, then it activates the whole turning mechanism. So we're going to create, I'm going to create 2 C# scripts. One for, I'll call it camera turn, even though it does the background as well. So camera turn, that'll do that. And then I'm also then going to create another one called turn trigger. And it wants to come in. Whoa. Yeah, okay. So I'm going to create a C# script called turn trigger. Cool. When those want to load in. So I'm going to open up this one and our camera turn over here. And now I'm also going to, before I forget, just add the scripts to these game objects right away. And our turn pivot is going to have our camera turn script. Will this use a Rigidbody? I don't think so. I think we can just rotate it via its own transform. Yes, that's what we will do. So now for the camera turn, I guess we could set up, just thinking about how I want to go about turning the camera. So it'll only be going to the camera pivot, only have 4 values that I can go to, being 0, 90, 180, and negative 90, or it could be 270, but then we also want to control, I guess, which way that we're turning, I guess. We could also then, we could set up 2 variables, one for where it's rotating, and then whether it'll rotate clockwise to get to there, or counterclockwise, just to be simple, because maybe we'll want to control that. So we'll need 2 variables for 1 where what direction we're turning to, and then 2 for what whether we're rotating clockwise or counterclockwise to get there. Which, yeah, we'll have to figure out how we're going to rotate, how we'll go between the two. So, anyways, we'll also need a turn speed as well, which, yeah, so it'll be like a turn smoothing, because it'll kind of start off fast and sort of slow down as it gets to that turn angle. So public float, float smoothing, and then we'll go for a float that'll be its current Y position target, I guess. It's like, yeah, the Y position it's currently trying to reach. So Y pause target, and that'll start off being 0, because I guess all levels will start off facing going up. Yeah. Yeah, so Y position target 0. We're also going to need references to our boundaries. So the only real difference then, if we set, or the only difference between how we're going to have to change our boundaries is that if we have the player facing this way, so Gizmos is turned on. If we then rotate the player 90 degrees and go back to our boundaries, they are very off. Actually, we might just, actually, we might be able to get away with how we modify the boundaries by putting that forward on the Z direction by 5, taking all this, moving it back by 5, 1, 2, 3, 4, 5, holding control, so it's a snapped increment. And then actually if I turn this, this still isn't, okay, let me undo all of that for one moment, back to before I turn it. Yeah, so back to before I turned it, when it was like this. Let me take these boundaries out of this child object there, move this forward on the Z-axis by 5, then take the boundaries and make them child objects of the boundary again, so it's in the same position as before. If we just take the boundaries and make them also a child object of the turn pivot, then they should theoretically turn too, except I'm going to want to take out the boundaries, turn the camera pivot back to its initial rotation, then put in the boundaries, and now I should be able to just rotate this. Yes, and now the player moves, like the boundaries will still be just relative to where the camera is, so now we won't have to worry about that anymore. But one thing we might want to do is, well, okay, we could disable the player's movement while we turn, but as the turn's only going to last a few seconds, we might not need to do that at all. So we can actually just save time by not disabling the player's movement. We can see how it looks. If there seems to be a problem with that. Oh, we will need to actually also change how the input works. But we could actually I think we could just smooth that out by making what way they move, instead of just being up, down, left, right, being those directions relative to the camera's forward direction, or I guess it would be not its forward direction, finding the camera here for a second. In local, it'll be its up direction, so we're going to multiply it by then the camera's up direction, so then as we're turning, it's still going to be up, down, left, right, relative to the way that the camera is facing. Alright, so let's do that. So that means we're going to have to go all the way to our player move function way back when we created that. And then we're going to add in the effects that we want for the camera. We're going to, I guess, need to get a reference to the camera for starters. So I'm going to get a private, a private game object. Actually, we only need the transform component, so I'll just get that. Private transform. I'm going to call it mcam because camera is a word that exists in Unity or in Mono develop C# for other things for the camera component on the camera game object, which we won't need, I don't think. So just getting a reference to the camera, which getting that, we're going to go, I think going camera.main. I believe that automatically gets the main, if I look at the description, the first enable camera tag main camera. I think that automatically gets the, oh, type name main does not exist in type camera. Okay, never mind. We'll just get the normal camera just with gameObject.find. So in start going, mcam equals camera, gameObject.find main camera dot transform. Yeah, and then down here we're gonna take this move vector that we had. I'm gonna put brackets around the whole thing, and then we're going to multiply it by mcam dot forward or dot up. Actually, no, multiplying vectors like that will not be what we want to do. Here we went, so vector3.right, vector3.forward. We'll make this mcam.forward and mcam.right, except because of the 90-degree tilt down on the camera, we won't want these to be right and forward. We'll want to switch them. So going up, we saw before, was mcam.up, and I believe, actually, I think right will be the same. Yeah, the x-axis is right, and it's still in the same right direction. So going mcam.right times the horizontal movement plus mcam.up times the vertical movement. So first of all, I'm going to go and just test that works first. So I'm going to go into play mode, and then I'm going to just see, first of all, if our normal movement still it works the way that it has up to this point. Cool, it does. So now I'm going to go and I'll turn our turn pivot to 90. Nice, and it worked. And then actually, I think whoa, something happened. Trying to have that 45-degree tilt might be more possible now, but what? Yeah, if I made this 45. Okay, actually we could. You know what? We totally could have then a 45-degree tilt, and that doesn't seem to be too disorienting or anything like that, as long as the up, down, left, right is just still within where we are moving. So, yeah, okay, we could totally do that. Cool, so we are going to do that. We'll set up a system so that we can have any degree tilt, I think, as opposed to just hard-coding the 4 directions. So, that's cool. So then, if we're going to do that, instead, so on the turn trigger, the thing that's actually going to call a function that we're going to make on the camera turn to actually turn the camera, the turn trigger is going to need to have a public float for the Y direction that it's going to turn to. And I think for now, I'm just going to ditch the clockwise, counterclockwise thing for now, just getting it to work, and then see if I can get it to choose whether it goes clockwise or counterclockwise. Although I don't know if we're actually going to need to do that at all. It might just be better to take the shortest distance one and turn that way. But so we'll go public. We'll need a float for Y, actually rotation, I guess. And that'll be what it'll set it to. We'll, I guess, set it to 0 should be the default, I suppose. And then when this collides with the player, so we're going to go void on trigger enter, and then we're going to go if other dot compare tag if it's the player. Cool. So if it's the player, then we're going to call a function that we're going to make on the camera turn, which we'll do right now, called public so that the turn trigger can access it. Public void turn, or start turn, I guess. Start turn, and then it's going to need the that float of where to turn to. So Y rot. Yeah, all right. And then actually this, I'm also just going to change that to rot because it's actually rotation and not position. So Y rotation target. So where it's trying to turn to. This should then, and then we'll also have a bool set up for whether or not it's currently turning. So private bool is turning with one n, is turning, and that'll start off being false. False. Also, this can be private because it doesn't need to have an initial value. As well, we don't need to set a default value for that, because if we do start the camera, we could start a level with the camera being facing on that 90-degree tilt or something like that. So we'll just set the Y rotation target to whatever the starting value is. Y rotation target, equals transform dot rotation dot Euler angles dot Y. Cool. And then in start turn, we're gonna set the Y rotation Y rotation target to the to Y rotation. And then we're going to set is turning to true. All right, and now we're going to go to the turn trigger and just call that function. But to do that, we're going to need a reference to the camera turn. So we're going to go private camera turn. It's a variable name, and then we'll get a reference to that camera turn. Because there's only one, we can go camera turn equals find object of type camera turn. Cool. And then this will call camera turn dot the function that we made was called start turn with the Y rotation that we made right there. All right, cool. So now we want to set up actually doing the rotation. So if is turning is true. Whoa, okay, so if is turning is true, then we're going to want to start rotating this. And how we are going to do that is by going to, so transform dot rotation equals quaternion dot slurp, so it's like spherical linear interpolation, something like that. It's like lerp, the linear interpolation, but for angles, because it's more spherical. It's what we're going to use. So we're going to want to slurp between where its current rotation is and a new rotation that is basically the same, but with this Y rotation target instead. So we're going to go quaternion dot Euler of a new vector 3, which is going to be transform dot rotation dot Euler angles. Actually, hold up, we don't need to do that because we know that the X part of that rotation is always going to be 0. Then the Y part is going to be the Y rotation target, and then this is going to be also 0. And then that should be it. No. Then finding my brackets there. So there, then we're going to want to set the this float t to be the smoothing value that we said, multiplied by time dot delta time, for the same reasons as with having things freezing by pausing as we wanted before. Now this may or may not work. I'm curious to see actually how this will treat values if we set them to like from 0 to 360, if it'll automatically treat it as 0 or if it'll do like a spin. That was my main worry before with why we may need to do clockwise or counterclockwise, but if it just hopefully works, then we won't need to do that, and it would just be better to just do the shortest distance anyways if it can do that. So now on our turn pivot, our smoothing, I'll set that to just 10, and then our over here somewhere, our turn trigger will set a Y rotation of 90 degrees. And let's test this out. And I am going to hope that it works. So we're going forward. This is working fine right off the bat. So after we go and pass our turn trigger thing, it's not doing anything. Maybe, or maybe it is. No, it's not. All right. All right. So now we're gonna have to figure out why it's not working. Where's our turn trigger here? I'm also gonna just set it a lot more forward. We'll just turn right off the bat. Also, before I forget, I want to set our pickup amounts back to what they were, which I believe were 10 and 15, which again can be changed. And then I'm going to apply this over there. And now we're also then going to want to make the turn trigger a prefab, but we'll do that when we actually get it sorted out. So now here, okay, I'm not seeing where is the turn trigger? It's there, okay. So as we come up on it, right, it doesn't move forward either. Okay, right, forgot about that. The illusion that we're making of having everything scroll through the player has messed with me too. So this turn trigger, we're going to have it move the same way we have everything else move, which is going to just be by, I just want to copy our player shot. Does it need a rigid body? I think it's, yeah, so it's going to need a rigid body and then a collider, then the shot move script, and then a destroy by time. Actually, no, we don't need to give it a destroy by time. We can just have that when the player collides with it and turns, then it'll just destroy itself. That'll be easier to calculate, I suppose. So we're going to have our turn trigger here, which is also then going to rotate. If we put the shot move on it, it's going to go based on its up direction. So I'm going to just rotate that by, on the x-axis by -90, so the y direction is pointing forward right off the bat. And then actually, yeah, these collider amounts seem to be fine. Actually, I guess I can just swap those just so it's the same. Actually, I can make it 5 and 5. Really big, just the player. There's not really any way they hopefully would miss it, but we're not going to chance that. So we have our turn trigger. Then we're also going to add a rigid body to it, disable gravity, enable all these constraints, and then we're going to add a shot move right there, and then a speed of, I think, what was it, 10? That was what we had. Yikes, we're gonna want to make this basically, we're gonna make this basically moving at the same speed of these enemies, but this moves at a constant speed. This moves with something different, I believe. It moves based on add force. It does. So I might actually give this the enemy move script, just so that it moves at the same speed as all our enemies, just so it's consistent, so it's not getting ahead or behind. Yeah, so I'm going to get rid of the shot move, and then add enemy move. And then I'll set that to, I think, let me look on our enemy turn and see what its speed is. 20. So we'll set that to 20 as well to match. So this, we're going to set it to 20. I'm just going to move it back just a little bit. Actually, I'll move it just, yeah, leave it right there. And then I'm also going to now make it a prefab, because I think we should hopefully be done with it now. It also doesn't get destroyed, but I'll worry about that in a second. I just want this to hopefully work. So going into play mode, and it's still not moving towards us. All right. So now let me try just rotating on a different axis. Whoa, okay. Right, the shot moves relative to the y-axis, but this does not. So we're gonna want to. This does move. The enemy move moves relative to its forward axis. So I'm going to undo the 90-degree tilt, but also give it a 180-degree turn, so that the blue arrow here is pointing towards the player, i.e. the way that we actually want it to move. So now we're going to go into play mode again. This should finally move into the player pretty much right after we start. Oh, yes, it worked. Although, just for pizzazz, I'm going to lower this a lot so it doesn't move quite as quickly. Just so there's some turning in there. All right, that looks cool. I think I'm going to make that even slower. I just want to see what it looks like at a really small value. I'm just going to move forward a little bit just so we get to start and then turn. Let's see what this looks like. Okay, cool. Yeah, so I'm going to turn that up just a bit. Let's go 4, and then I think that'll work as well. Back to our camera turn. I didn't end up actually using this at all. I could make it that so that once it actually reaches its turn location, then it could I could set this to false, but I don't think that'll be a problem. You know what? We will do it because optimization and stuff. So it's not trying to still turn and do all its calculations when it doesn't need to. So if the transform dot, no, there's a quaternion dot angle. That's it. Actually, the only thing that's going to make a difference is the rotation target and its Euler rotation y. So if math f dot absolute, absolute. So if the absolute value of transform dot rotation dot Euler angles, no, not to the next line, back that all the way up, dot Euler angles dot y, subtract the y rotation target. So if this minus this, the absolute value to make it positive is less than 1 degree, or, yeah, actually maybe just a little smaller, 0.5 f. Or so if it these are pretty much the same, then we're going to, in an if statement, make it exactly the same. So transform.rotation equals this whole thing over here. So just setting it to that exact value. And there seems to be some angle or some bracket problems in here. I think that just has one too many. Yes. And then this needs one more. Perfect. And then we're going to set is turning to false. Okay, so now that seems to work. Now, I'd like to try out some other things quickly. I'm actually just going to disable all of our enemies for a minute, just so we can not have to worry about living. So I'm going to take this, move it forward. That'll set it to a 90-degree tilt. I'm also just actually going to move this down. Okay, actually, I'll open the prefab instance. Then I'm going to move this down all the way to the bottom, just so it's easily seeable, since it's the only real thing that we're going to want to change on our turn triggers. So now, duplicating this, I'm going to move it to there, and then I guess I can set this to 180, and then duplicate it again, put it over here, set it to, I want to just see what happens if we put it to -90 instead of 270, and then one at, over here, at 0, and then one over here at 1000, and we'll see what that does. So if all of these work properly, then we will be good to go. Just trying out a bunch of different potential scenarios we could come across. So now we hit this, we turn. Whoa, that worked, but I wasn't expecting them to be so close. Are they... don't know if they're moving right, because I feel like they're moving a lot faster than our enemies. Drag 5, that was it. Setting this drag all the way up to 5. Okay, that was really quick. Way quicker than our enemies were moving. So now we come in, fighting enemies, pew pew, boom, now we turn. And if we're on the edge of the screen, just making sure that we don't get like pushed out or anything. Cool. And then if we're on the edge of the screen over here. Now, oh, see, we do have a problem where we can get pushed out of the boundaries and be forever lost. And then pushed back in. Now, okay, that would be because our boundaries are getting, like, moved. And that's just being a problem. So I'm going to actually add kinematic rigid bodies to all of our boundaries so that when they get moved around, they hopefully shouldn't do that. Like, the player should still be able to sort of push off of them. I think that'll work. So now when they get rotated, let's try this again. I'm also going to select all these just so we can see. No. Okay, so we still have problems with being pushed out of our boundaries. That's not what we want. None of these have rigid bodies on them. I was thinking having a kinematic rigid body would work. If we don't make it kinematic, then the player will be able to like push off them, which is really not what we want. Let me... We could try rerouting the turning to be done with physics. So we could actually give this a rigid body. Get rid of the rigid bodies on all of here. Give this a kinematic rigid body, and then instead rotate our player... rotate this using physics instead of just transforms. That should hopefully make the colliding work better, which means we're going to then need to get a reference to the rigid body component. So let's do that. Private, rigid body, RB. Then in our start function, we're going to want to get the reference to that by just going RB equals get component rigid body. And then we're going to want to set this. If I just went RB.rotation equals for all of this, I don't 100% know if this will work. I mean, the alternative, actually, let me see if there's like a function called like set rotation. Set, what can we do with the rotation? Move rotation. Rotates it to rotation. So let's go rigidbody.move rotation, which is a function. So move it to all of this, which means more brackets. Yes. So then if replacing all these transforms for rigid bodies equals that new Euler, that, and then this will also be dot move rotation. Yes. That hopefully should work. Alternatively, I might have to add torque or something, and then I could set up the angular drag, but I'm hoping to not have to do that. Yeah, so now all of these set up, that should hopefully work. Let's find out. Actually, one other thing I want to do, I just want to turn down the smoothing a little bit more, which could also help, but we're about to find out. So now going in here, selecting all of this just so we can see. Oh no, boop, we turn. So now I think we are banging off this, which is nice. That's what we want to happen. Let me just move to the corners of the screen, wait for the next one to come in. Boop. Yes, we're not leaving the game area. That's good. Perfect. That's exactly what we want. And for the most part, we'll be in the center of the screen anyways, maybe being along the bottom, but I don't think we're really going to be in the corners that much. So that should be fine. And then we can also be rotated on an angle, and that seems to work fine. So lastly, I just want to see what it's like if we take... I'm going to set that to 2. I want to turn back on all our enemies. All these turn triggers, they kind of make it to the end. They do not. I want to try just placing these kind of in between each section. I'm going to have each enemy section be further apart and just sort of see what this looks like so we can get a feel for it in actual potential gameplay. I'm actually also just going to make these spaces not quite so big. All right, so now we did that. Now I want to go to all my turn triggers, have one here immediately after our hazards, one after in the middle here, one over here in between these enemies, and then one over here between those. Oh, and then I guess we can have a final one. That doesn't really help us, but actually I'll delete that. And then I guess I'll take this and set this to a Y rotation of, I kind of want to just see what it looks like on an angle of 45. Let's go 40 just so it's even weirder and seeing if it actually works. Actually, let me go 40 plus 90. That's 130. All right, so another thing about there, when you're typing in values, you can kind of type in math stuff and it'll calculate that stuff automatically in cases like that. All right, let's see what that looks like, just to kind of test it out. Oh, actually, okay, I was thinking I was forgetting something, but yes, I know what it was. I want to go over here. When it calls this, I want it to destroy itself, so we don't activate one of these twice when we don't want to. So destroy game object. Yes. Just so once a trigger is used, it's gone. All right, so now we're going forward, and I won't be having... I'm going to turn off our gizmos just so we have the actual genuine experience of knowing when we're going to hit colliders. So now we turn. Alright, that's cool. So now we're shooting on the side. We'd also want to fiddle with how high up and down these enemies are. Just because. Now it seems also turning, it seems to potentially be a bit better when all enemies are off screen. So it looks like it's the player ship actually turning. And we died, unfortunately, so I'll have to... Actually just going to go and... we don't have any other sort of cheats that can give us invincibility. I'm just going to I'll turn on my shield. And then just hide to the side. So going through this, that seems to be working. Alright, so I'll let it get to the end here, but at the same time I'll say that is basically going to be it for this episode. Next time, I think we'll finally make our level complete system. So we'll put this score system to use. We'll make it so that when we hit the end of a level, we'll actually, when we hit the end of a level, we'll have an actual level complete thing, and then it'll test if we've actually hit the required score. In fact, actually what we could do is change the score bar to be like a slider, so we can actually see in the middle of the level how close we are. So the more score we get, it kind of fills up until it gets to the end and it gets green, and then yay, we've gotten all of our score. And oh yeah, so now we're on this tilt, and this actually, I think it's fine. Like I made the game, so I know how it works or whatever, but I'm not seeing any disorientation problems with being on this weird angle. Oh, I'm just looking in the background and noticing that our planets are spawning in and out. That's not what we want. Okay, let's do one minor thing and fix that as well. So over back on our background, I think we can just fix this by increasing these boundaries by a lot. How much though? That's the question. So I didn't really see what axi those were on. Not going over there. I want to go over to the camera. So the ones that are on this axis, when we compress it a bit, when they go on this axis. So if we make it more of how they spawn in being like a square, and then overestimating a little bit, then that should be fine. I think the stars were fine. So the z-axis was the smaller one. So let's set all these to 65. 65, 65, 65, and 65. I'm also going to allow our stars to be slightly more in the distance. Maybe that'll help. Just so they look more distant, I guess. Or sorry, that was our planets. I'm also going to take our stars, our 200 of them, and I'm also going to set... No, I'm not going to. Also, actually, hold up one more second. Because I made the background stars able to be lower, they have the potential of being further away. Like these are going to need to be ever so slightly bigger. So I guess this is going to be 70 all around then instead. Hopefully that'll be fine. If we notice it's not fine, then we can just adjust it. All right. Cool. So now that'll do it for this. So next time we're going to make the level select. We'll also maybe have like a progress bar on the side that shows how close we are to the end of the level, which, because the level only moves in one direction, we can just measure that as a distance between the start and the end point to get what the whole distance is, and then the distance from the player to the end to know how far along we are. And then if we have that over here, we might move the score to the other side just to have the same amount of stuff on both sides of the screen. And then we'll make the score system also be a bar of going from up to however much score you need to pass the level. And then we'll make a level complete screen that'll then probably also go to our temporary level select. So now, yeah, our game's slowly fleshing out more. We're getting close to being done this template level. Once we're done this, then we'll be able to make more levels, and just based on how much stuff we have, we'll be able to make lots of unique levels really easy by just duplicating stuff and pasting it around. But anyway, so that will do it for this episode. Thank you all so much for watching, and have a good day!